In this video, we're going to be drawing a kite and labeling the vertices A, B, C, and D. Before we do that, let's remind ourselves what a kite is. So a kite is a quadrilateral in which the two consecutive sides have equal length and the remaining two also have equal length. So in this kite, we know that AD and AB are consecutive and have equal length, and then BC and CD are consecutive and also have equal length. So for our kite, we're going to make sure that the consecutive sides are equal. So here's our kite, and now we have to label the vertices, which are the points A, B, C, and D. So this one will be A, this point right here will be B, this point is C, and this point is D. So next we're going to be drawing and naming a line of symmetry. We know that a line of symmetry is a line that separates a figure into two congruent shapes. So in this example, this is the line of symmetry and it separates this into two congruent shapes. So the way we can do this is just drawing little practice lines, well, fake practice lines. If we have one here, we know that this shape is not congruent to this shape, so that can't be the line of symmetry. The same for this one. This shape is not congruent to this shape. And if we draw one right here, I'll just draw this one in so it can be more clear. This shape is not congruent to this shape. So if we go through A and C, let's see if that is a congruent shape. I'll erase this one. We can see here that this shape is congruent or equal to this shape. So that is the line of symmetry. So I am going to draw a little line here. And we can write that the line of symmetry is this line right here, so AC. And we're going to pretend that that line keeps going, so it's an actual line. So we'll name it AC. So now we're going to try a little folding exercise and see how we can find the line of symmetry. So now I have this kite that I created. It's the same one from the other picture. I just cut it out. We have the same vertices and everything. And so for our kite, to find the line of symmetry, all we're going to want to do is fold the paper, and where the folded, when the folded part sits perfectly on top and all the edges are matching, that's how we know that's the line of symmetry. So we're going to keep folding until the paper perfectly aligns. So we can try A to B. And you can tell that's not perfectly aligned, so this is not the line of symmetry. We can try D to A. Once again, the paper is not perfectly on top of each other. It's not perfectly aligned, so it's not the line of symmetry. A to C. Because we have this little leftover, the paper is not perfectly aligned, and therefore it's not the line of symmetry. So we can try A and C going through there. And you can see that because it perfectly aligns, this is the line of symmetry that goes through A and C. So I will just draw a little line, and we'll know that that is the line of symmetry. So what does this line of symmetry show us? Are there any angles that are equal? And does the line of symmetry show us that? So we can't say that A and C are equal. The line of symmetry does not show us that because, once again, if you put them on top of each other, you can see that there's not equal. There's some leftovers. And we know that A and B aren't. Once again, leftovers. A and D, there's leftover again. And so if we fold it on the line of symmetry, we can see that this angle is congruent to this angle. So we know that angle ABC is congruent to angle ADC. So let's write that down. So we know we'll write equal angles. So we said that ABC, so angle ABC is congruent to angle ADC. And now what else does this line of symmetry show us? What does this line of symmetry bisect? And before we do that, let's remind ourselves what a bisector is. So a bisector is a ray, a line segment that separates an angle into two equal measures. So we have here, and let's see if this line, what angle is this line of symmetry bisects? So we know it goes through angle A and C, so most likely it's going to bisect angle A and C. Let's see if it creates two equal measures though. So if we fold it, we can see that this is congruent to this. So it does create two equal measures because they're perfectly aligned. So we know that the line of symmetry, this AC, is bisecting angle BAD or an angle BCD. So we can write that down. Angles AC bisects, which is angle BAD and angle BCD. And that's our kite.